Okay, let's try to solve this binary search question. So here given a two number n and q, array A of n numbers are there, and q queries, each one contain the number x. So we have a q queries and we have a array A which contain n numbers. So for each query, print a single line that contain found the number x exists in array A, otherwise print not found. So where the constraint is n is 10 raised to 5 and the q is also 10 raised to 5. So if I write the brute force here, so you will see that the test case are unsorted, which is not sorted. Okay. So if it is not sorted and we are doing the linear search, so our time goes here for n. For every query, we have to run the n times. So that means we have a q query. So we have to run the n into q times. So what is n into q? N is 10 raised to 5 and q is 10 raised to 5. So how many operations should I do? How operation you have to do is 10 raised to 10 operation. Okay. And we have a 1 second. We really want to say we have a 10 raised to 7 operation in 1 second. So it is 10 raised to 10 is bigger than. So we have to do something like that. Okay. So how to do it? For every query, if I do in log, think about like if I do in log operation. Okay. So if I sort the array first, let's try to sort the array. Okay, let's try to sort the array. So whenever you do sort, we have to take the condition n log n. Okay. Now after sort for every query, you have to do find the number exist or not in array. We have to do the log of n operation, which is binary search. So O of n log n is we have to make the sort of the array plus q into log n. This is a time complexity. And if I do this one, so q is 10 raised to 5, q is 10 raised to 5 into log n is 10 raised to 5 is around 23. If I do log 10 raised to 23, so which is less than 10 raised to 7. So this code will work. This time complexity works here. Okay. So n into q will not work. So we have to do this time complexity o of q into log n. Okay. So o of n log n plus q into log n. Okay. That is our time complexity of the code. So we have to do the first sort, because why are we doing sorting? Sorting help us to do binary search. And for binary search, we have to do only log n operation per query. So we have a q query, so q times log n. Okay. So let's try to write the code. So we have a STL2. Okay. So we have a STL standard template library. We have a STL seed. We can try it. So ln comma q scene n scene q vector v of n or lli less than I plus plus scene v of I. So here we see that for every query while q minus minus, we have element llx scene x. Okay. And this is a STL I will really want to do with this is STL binary search. Okay. First one, what should I do here? We have to short v comma v plus n. You have to do as an array. This is also works, and you can do something v dot begin comma v dot end, because v is a vector works here. Okay. So binary search v dot begin comma v to end comma x. If it is present in present in the array, we found it, else we don't have to found. See out not space found. So not के बाद space, we have to consider this space after not. So whatever the expected output are there, we should print like that. Okay. You must print similar like that. So this is the STL. Okay. This is the STL. And this will the time complexity of this sort is O of n log n. Okay, and for every query q we have to do log of n operation, so q into log n. Okay, so see that we can do this code without STL. Okay, let's try to do without STL. So our code is accepted. So we can do this code without STL. Okay, so how do I check it? So ll start equal to 0, end equal to n minus 1 because it is the last index of array, while start is less than equal to end. We have to implement the binary search code here. ll mid equal to start plus n minus start divided by 2. If v of mid is equal x, then we have found it. Okay, we have found the element, so I can write is here bool flag equal to false, so flag come true. Okay, else when I found it we need to break it. Else if we have two condition, if else if v of mid is greater than x, and else if v of mid is less than x. So what should I do if greater than x? Think about, like, for this statement, think about it and understand this one. So we sort the array, it become 1 2 3 4 5, and it start with index 0 1 2 3 4. Okay, so if I just find what is mid, 0 plus 4 minus 0 by 2, so 2, that is our mid. And we really want to find the what is 4, like we x equal to 4, let's suppose x equal to 4. So we are getting like v of mid. Is v of mid equal 4? No. Is it v of mid is greater than x? No, v of mid is less than x. So think about it. Start is here, end is here, and mid is here. And now v of mid is less than x, is less than 4. So we don't need to check here because it is must be answer is in this range. So we move s here and we move have s equal to here, mid plus 1 become s. Now the space is here, and we are really do the we really do the again binary search. We really do the find the mid statement from this. So here is not there, so mid plus 1 is equal to s. So in this case, if v of mid is less than x, so start will become mid plus 1. Okay, see the if x equal to, think about it, is x equal to 2. So v of mid is greater than 2. That means we have to end here, and end is become here, and mid minus 2, because in this space our 2 is present. So end will become mid minus because it is not in present. So we really just avoid this range. So end will become mid minus 1. Okay. So if flag equal true, that means we have found it. So we just have implemented our own binary search. If it is not, just write this code. Let's compile and run and check it out. Is it working or not? So we are implementing our own binary search here. You can use STL too. So now it works. If you have still doubt, you can ping us in one WhatsApp group. We have a WhatsApp group. You can check out on LinkedIn profile. You'll get it there. So binary search. So what is the time complexity of this code? O of n log n plus q log n, and which is less than 10 raised to 7 operation. So you'll see that. So accepted our code. Let's mark the code. Let's mark the question.